All right, welcome back. I hope you're having an awesome time so far. Our next speaker is Archie Agrawal. She is the product lead at Amazon. Please join me in welcoming Archie to our virtual stage.
Hey everyone, I'm excited to be at the AI4 Retail Conference 2021 and talk to you about connecting machine learning to business problems. Before we begin, I want to start with a disclaimer. The views expressed in this session are my own and not of any of my current or previous employers. Let's get started with introduction and session details. I'm Archie Agrawal, a product lead at Amazon, working on a large-scale machine learning initiative to appropriately handle user-generated content in the Amazon store. Previously, I was at Microsoft Azure, working on making identities simple, secure, and easy for developers. And before that, at Bank of America, working on fraud and abuse in the digital banking. Over the course of my career, I've been at all sides of machine learning, from science to engineering to business. I've built models in production in both academic and industry setting, also built the infrastructure and engineering to deploy those to production. I went to school at Carnegie Mellon, and I love reading, hiking, bouldering, and prefer tea over coffee. I want to share a little bit about why I chose this topic for today. In my own journey of over 5+ years in the industry, I felt that there is a lot of information online about machine learning geared towards technical audience, which is scientists and engineers. However, very little information is available for business leaders. I'm here to explain how powerful machine learning can be to drive business value, mistakes to avoid along the way, and share the frameworks to evaluate any problem, all while taking relatable real world examples. Let's dive in. So, here's a high level agenda for today. Firstly, we will cover when not to use ML. Most industry machine learning projects fail, and at the end of this session, you will have all the information to lower all the probabilities of failure and to not fall into the machine learning trap. Secondly, we will get into the dirty laundry of machine learning in practice with this really simple and interesting case study. Here, I will share with you things no one warns you or tells you about machine learning, so you don't have to learn the hard way. Hard way could be getting into regulatory trouble or finding bad PR about your company or by losing customer trust. We do not want that to happen. After that, we will get into the nuances of machine learning in industry. While it may sound great tactic on paper, let's dive in. How does it all work practically? And finally, we will wrap it up with key takeaways. So, you hear about machine learning and all its greatness in the media all the time. From computers defeating humans in Go, self driving cars, to more commonplace scenarios like personalization and recommendation. Maybe when you look around in your own organization, you may be wondering, why doesn't it work at my company? Or maybe you want to champion using machine learning for some of the problems you have. Whatever your situation might be, in order to truly harness the power of ML, it is important for you as a business leader to understand when to use machine learning and when to not. Let's walk you through a few examples and provide you with a framework you could apply to any scenario. Now, let's take a few examples to understand this better. Now, let's say the problem at hand is to determine where should Amazon establish their HQ to. I want to pause for a second and have you think if you would use machine learning for this problem or not, and why. Now, some of you may believe you should, others may not, for your own valid reasons. I personally believe that this isn't the right problem to use machine learning for, and that's because it's a one time problem and not a recurring one. Machine learning is expensive and adds all sorts of engineering complexity. As a result, adds tons of technical debt. You need to set up the right data pipelines integrated with production systems, which may be on a separate stack. You would have to take care about interoperability with machine learning stack, explainability, etc. Now, let's take this other example. Here, we need to determine where should Amazon open new warehouses. Now, that sounds like a recurring problem. Just following the principles of software engineering, it is a build once, use many situation. So all that effort might be worth it. Next time, ask yourselves, is this a single occurrence or a recurring problem? In this next scenario I have, it is that your e-commerce store just launched. Classic recommendation problem. Which product should I recommend to my customers? Now think about this one for a second. You've just launched and recommendation seems to be the next logical choice. Here, it may sound counterintuitive, but I would not again recommend using machine learning for two main reasons. First, quality data. Since you've just launched, you may not have all the data that you need and the quality that you need to get meaningful results from a model. Most machine learning models need large amount of data to be trained and tested on. The second reason is you can probably just get away with using simple rules or other growth hacking techniques. In most cases, if machine learning takes you 80% of the way, other simple techniques can take you at least 50% of the way. So you need to understand the incremental value of that data, whatever it looks like for your business. To sum it up, machine learning is seldom a great first step. It's most effective in later stages, and make sure to try simple things first. Do not jump on the machine learning bandwagon just yet. Wait until you have the right data. Next time, ask yourselves, is this the right time to use machine learning? Now, based on these two scenarios and what I've told you, it seems like machine learning could be the right path as long as it makes business sense, you have the right data, and the problem qualifies to be a machine learning problem. Here's when things get tricky. Let's take the next two examples. The first one, which is which resume should I consider for open positions at my company? And the second one, whose mortgage application should be approved and at what rate? At the surface, both of these are great business problems. However, be cautious of using machine learning when that may unconsciously result in propagating bias or discriminatory behavior. You could go really wrong in both of these cases, especially if you're a larger organization. Do not champion projects that may yield into unethical behavior. And just because you have the right data and it makes business sense, doesn't mean that it's a problem worth using machine learning for. So, the next time around, ask yourselves, is this propagating societal bias and discriminatory behavior? If your answer to either of those is yes, then please stop. We have to ask ourselves, how do we make systems learn the right things? And who even decides what the right thing is? Thanks to FATML, which is Fairness, Accountability, and Transparency in Machine Learning, we have some of the best researchers and practitioners from across the industry working in this area. Now, to sum it all up, picking the right problem is what it boils down to. Anytime you're presented with a situation, ask yourselves these three questions. First, is this a single occurrence or a recurring problem? Is this the right time to use ML? Third, is this propagating bias or discriminatory behavior? Now, let's take an example from Airbnb. And I also want you to consider that outside of those three questions, please top it off with long term thinking and setting the right business goal. Going back to the example that I want to take from Airbnb. As a business leader of the company, does this sound like a right goal to you? Increase the per night bookings on the platform. I will pause for a bit and have you think about it. If you believe that's the right goal, you could do so by recommending and boosting great Airbnbs in search ranking. show the very best on page 1 and page 2, and you could draw a similar parallel to e-commerce stores as well. However, in doing so, new Airbnbs might be neglected. So while your per night bookings may go through the roof, customers will never discover newer listings. And as a result, the overall health of your marketplace may worsen in medium or long term. So never get dissuaded by short-term profits, look around corners, and set the right goals for your business. Now it's time for a case study. You have determined that you want to use machine learning to ban accounts for corrupting the health of your marketplace. You have also built a great team, hired PhDs and top notch researchers and scientists who are top of their field. We all know that the 5 step way to build and deploy any model is: first, get the data you need. Second, do the modeling. Third, test and validate the model. Fourth, deploy it in production and profit. How hard can it be? Let's walk through what happens when machine learning comes into picture in industry use cases. Now, let's understand what really matters in industry. In industry, machine learning infrastructures matters more over state of the art algorithms. While machine learning in academia is 90% about machine learning and 10% about engineering, machine learning in industry is just the opposite. It's 90% data engineering and only 10% machine learning. In industry, models needs to be integrated with engineering system to deliver customer value. Productionizing machine learning is a huge deal of engineering feat. It isn't just about getting machine learning systems to the end user. It's also about building the infrastructure with monitoring and alerts so that when something goes wrong, you're set up to roll back updates and course correct. And things often go wrong in real world. For machine learning and industry to work, table stakes isn't about state of the art algorithm. It goes beyond the algorithm and needs to work end to end. The next thing is model explainability. Here we will cover bias as well as regulatory requirements. Many models operate like black boxes. However, in case of a customer impacting critical decision or due to compliance and regulatory needs, you often need to consider explainability. Let me share an example. At Amazon, we use models to make variety of decisions just on the basis of machine learning. Oftentimes, customers would appeal that decision and ask us to explain, why did I receive this decision? Or what did I do wrong? Or how can I fix this? All fair questions. That questions is often asked to a frontline ops or customer service representative. They're all non-technical audience. Now, one way to handle this is to raise a ticket to our science and engineering team every time this happens. However, imagine the operational load they'll have if this happens every single day at Amazon scale. Soon enough, they might leave the team or have a ton of burnout. Nobody wants that to happen and it won't scale. Therefore, in order to scale effectively, we need to build internal tooling for non technical frontline employees to equip them with the right knowledge to serve our customers. In many cases, you can't accept the black box nature of machine learning as status quo and need to work around it. Otherwise, you may end up losing trust with your customers or fall into regulatory trouble, or both. The next thing I want us to think about is cost and performance evaluation. For machine learning models to work in the industry, you need to deeply understand the customer and business value behind it. One way to do is to quantify the cost basis of a false positive and a false negative and design your models accordingly. Some scenarios warrant high precision and can tolerate low recall. For example, email spam detection. When you detect an email as spam, you could do it with high probability of detecting correctly. You may be okay letting some of the spam through in the inbox. However, you might not be okay marking a legitimate important email as spam. Another example could be in case of parental control feature or features like restricted mode, where you restrict violent and adult videos for kids. Here as well, you need to operate with high precision. If a model has classified the video as safe for kids, it must be safe for kids to watch. In other scenarios, it could be vice versa, where you need high recall and can tolerate low precision. For example, when you have to catch maximum and a little bit of false positives may not have adverse effect. For example, running a promotion or showing personalized ads. In some other cases, you may have to balance. The great thing about machine learning is that it gives you the flexibility to choose your operating points and balance the trade-offs between precision and recall. Another thing to consider is there is no leaderboard in the industry like it is there in academia. It's all up to the scenario and the business case. Make sure you deeply understand the cost of building models and the results you are getting from it. Now, finally, if there are three things I want you to take away from this session, they are as follows. First, machine learning is expensive and not a magic bullet. Start simple. When you've redlined your simple options, be prepared to jump on the machine learning wagon and make sure your business really needs it. Second, state of the art algorithms aren't table stakes in the industry. As you fund machine learning teams, ensure that engineering and machine learning infrastructure are equally important and well resourced. Third, with great power comes great responsibility. Make sure you have mechanisms in place to manage bias in machine learning models. Lastly, I hope you enjoyed this session as much as I did. I would really appreciate if you could leave me feedback on today's session. I promise it only takes a minute and I don't ask for any personal information. Thank you once again.
Awesome. Thank you so much, Archie. That was an amazing presentation, and we really appreciate you sharing these insights with us. I know the audience is giving you a big virtual round of applause.
Thanks for having me.
Thank you. All right, for the audience, it's time for you to make your way to your next session. And along the way, make sure you accept your connection request and check out our amazing AI exhibits. Thanks so much, and we'll see you around.